Hi, Anne. I chose to make this as a video because I want to be able to point at some different images to give you an idea of what we're talking about. I'll also include the images in the email along with a link to this video. So your question was about, if I'm reading this correctly, the cotangent 5 pi over 9 radians and how they knew that that was in the second quadrant. Your analysis that you haven't read is correct, that if you change the radians, which is what 5 pi over 9, that's in terms of radians, if you convert that into degrees and you change that to 100 degrees, then that would be in the second quadrant. And that's true. That is certainly one way to do it. That doesn't really help you too much with finding the reference angle, although it's possible. Let me at least show you where they're getting the 5 pi over 9, how they know that that's in the second quadrant, and talk about the reference angle for the negative cotangent and whatnot. So I'm going to point you to this picture here, this image. This is the unit circle. There's lots of images out there of the unit circle. This is certainly not the best one, but it's here. So on the unit circle, if you start at 0, and hopefully you can see my cursor here, you can start at 0. If you go counterclockwise around the circle, then you could look at that in terms of degrees. You'll notice it has 30 degrees here, 45 degrees, 60 degrees, and so on. So 180 degrees is half a circle, halfway around, 360 degrees all the way around. If you're looking at that in terms of radians, halfway around the circle is 1 pi radian, and all the way around the circle is 2 pi radians. And we can see that show up in a graph too. This is the sine and cosine graphs. If you look at the period for cosine, which is in blue, it starts here at 1, 0, 1, and that's right at the beginning. And if we follow it at pi radians, we're at -1, which is kind of halfway around a circle. And if you keep going 2 pi, we're back at the beginning again. We've gone full circle around that unit circle. Same thing with sine. We start at 0, halfway around, we're back at 0, and then we're back at 0 again with 2 pi. And so we're that halfway and that full way around the circle in terms of radians is pi radians and 2 pi radians. Okay, now talking about, I'm breezing through some of this, but if we're looking at the root, like the root 3 over 2, the root 2 over 2, and so on, as you go through these radians and you break it up, pi over 6 radians, pi over 4 radians, pi over 3 radians, we can get these different trigonometric solutions, or trigonometric parts of it. And that deals with, and actually I think that shows up in the image here, with your SOHCAHTOA. If you remember that, sine is equal to the opposite over hypotenuse, adjacent over hypotenuse for cosine, opposite over adjacent for tangent. So these numbers here come from those ratios, those trigonometric ratios. So like if we look at 2 pi over 3, it's right here. So pi over 3, we're 1/3 of the way around half of the circle. 2 pi over 3, 2/3 of the way. 3 pi over 3 would be right here, just pi, 3 pi over 3. And if you made a triangle here and you did your sine, cosine, tangent, this would be your cosine, a half. This would be your tangent, root 3 over 2. 2 pi over 3, you'd have a cosine of -1/2 and a sine of root 3 over 2. And the way they're getting the cotangent, just again, I without being able to talk to you, I'm trying to give you as much as I can. And this might be more than you need. But the cotangent is, if you remember, tangent is equal to sine over cosine. Cotangent then would be cosine over sine. So the cotangent is listed here for 2 pi over 3. Cotangent is negative root 3 over 3. So if you take the cosine over the sine, -1/2 divided by root 3 over 2, and you did your arithmetic, you'd end up with negative root 3 over 3. So if they had asked, and I know this doesn't quite answer your question, but I'll get there. If they had asked what quadrant is the cotangent of 2 pi over 3, well, 2 pi over 3 is right here, and it's in the second quadrant. So that's where 2 pi over 3 is. Now, this unit circle and most unit circles that you'll see are broken up into thirds and fourths. That's it. or excuse me, not thirds, sorry, sixths and fourths. So we got pi over 6, 2 pi over 6, if you reduce it as pi over 3. So this is 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, and so on. And then the fours as well, fourths. So it's not broken up into ninths. Your question was specific to 5 pi over 9. So we would have to guesstimate a little bit here. Because ninths isn't really halfway here. It's kind of right about there. This would be like pi over 9, give or take, where my cursor is. So you could kind of count it out. But remember that pi over 3 would be 3 pi over 9. So this is 3 pi over 9. This would be halfway, so like 4.5 pi over 9. That's not a great way of saying it, but this would be like 4.5 pi over 9. So 5 pi over 9 would be right about here. And that does match with your 100 degree. When you convert it into degrees, it'd be 100 degrees. So it is in the second quadrant here. And that's how they knew it was in the second quadrant, is they were looking at this unit circle and said, well, 5 pi over 3, or excuse me, 5 pi over 9 would be a little bit past halfway, half a pi, which would be right about there. And that's in the second quadrant. Now to answer your question about the reference angle. So what we want is, I'm going to go back to this 2 pi over 3 because it actually shows up on here. So that's where 5 pi over 9 is right about there. So I'm going to go back to 2 pi over 3. 2 pi over 3 has a cotangent of negative root 3 over 3, has this sine value and this cosine value. Your idea that you expressed right at the bottom here, that cotangent of 5 pi over 9 is equal to negative cotangent of 4 pi over 9. That's correct. That's exactly what we're looking for. We're looking for, which other point on this graph is going to give us the exact same result for cotangent. That's, in essence, what we're looking for. And it ends up that the other one that's going to give us this, the way we kind of need it, this negative root 3 over 3, is going to be right over here. Over here, cotangent negative root 3 over 3 is at 5 pi over 3. In fact, it's always going to end up being 180 degrees from the positive angle. And a reason that we end up getting the same cotangent, the same result, even though if you look at the sine or the cosine and the sine here, cosine is a half, sine is negative root 3 over 2. Cosine negative a half, sine of root 3 over 2. Even though the sine and cosine are opposites, if you're dividing, because that cotangent was cosine divided by sine, if you're dividing, a negative divided by a positive is negative, and a positive divided by a negative is negative. So by replacing or flipping the positive and the negative of those two values, when you make that division, when you find the cotangent, you end up with the same result, negative root 3 over 3. So it's always going to end up being 180 degree rotation from where you started. Getting back to the 5 pi over 9, 5 pi over 9 was right about there. So if we take 180 degrees, we're going to end up right down here, which is just a little bit less if you're going the opposite direction now. So we're going negative. So instead of going in a positive direction around the circle, we're going clockwise, a negative direction. A little bit less than 4.5 pi over 9, which is just 4 pi over 9. So that's really getting that reference angle from. So if I want to know what's the reference angle for 2 pi over 3, I would say it's going to be 5 pi over 3. If I want to know what's the reference angle for 5 pi over 6, I'm going to get 11 pi over 6. And that's, well, excuse me, not 11, I apologize. No, I said that wrong. 5 pi over 6 is going to be pi over 6 because you're going backwards. So that's just 1 pi over 6. And for 2 pi over 3, it would end up being pi over 3. So this would be pi over 3 going backwards, and this would be 2 pi over 3 going forwards. And they're opposites from each other. So the reference angle, 5 pi over 9, we go back this way, 4 pi over 9. I hope that helps. If I didn't answer your question fully, or if you want more, please let me know. And I hope you do well on the quiz. Try and stop it here.